Hi folks, we're going to take a look at the solution for number 14 from part A of the Unit 3 assignment. So they give us this function here and they want us to show that the second derivative is positive for all x values except those where the absolute value of x is less than or equal to 1. Okay, now here recall that this expression is just another way of writing negative 1 less than or equal to x less than or equal to 1. Okay, so all numbers between negative 1 and 1 inclusive. Okay, so let's start by finding the second derivative. So find the first derivative first. So here we use the chain rule. So ln of u, derivative of ln u is 1 over u. So 1 over x squared plus 1 over x squared minus 1. Okay, times the derivative of u with respect to x. So I'll use the quotient rule there. So derivative of the numerator is 2x times the denominator function minus the numerator function times the derivative of the denominator function. Okay, all over x squared minus 1 squared. Okay, so let's simplify this as much as we can. So this is just taking the reciprocal. So it'll be x squared minus 1 over x squared plus 1. Okay, times, so here we have 2x cubed minus 2x, and then we have minus 2x cubed minus 2x, okay, all over x squared minus 1 squared. So first thing I notice here is that x squared minus 1 will reduce with one of those x squared minus 1s, and then these 2x cubes cancel each other out. Okay, so y prime is equal to negative 4x over x squared plus 1 times x squared minus 1. Okay, and I can actually rewrite that in a nicer way since this is just going to generate a difference of squares. So negative 4x over x to the fourth minus 1. So if I were just to expand that out, I'd get the difference of squares. Okay, and this is pretty nice in order to find the second derivative. So let's do that now. So use quotient rule again. So derivative of the numerator, negative 4 times the denominator function, okay, minus the numerator times the derivative of the denominator function. So that's 4x cubed, okay, all over x to the 4 minus 1 squared. Okay, so here we've got negative 4x to the 4 plus 4, and this will just be plus 16x to the 4 okay, and so here negative 4 plus 16, so we have 12x to the 4 plus 4 over x to the 4 minus 1 squared. And there's our second derivative. Now when we take a look at the second derivative, we see, well, the numerator is being squared, so this will never be negative. Okay, and the numerator is, well, that's a strictly positive number, and I'm, or 0, and I'm adding 4. So the numerator will always be positive. Okay, so this so far seems to fit what we're trying to show. Okay, so let's figure out where this issue with it not being positive when x is between negative 1 and 1 inclusive. Okay, so first of all, this won't be positive when the denominator is equal to 0, obviously, but the denominator won't be 0 when x is equal to plus and minus 1. Okay, so that certainly explains why these two numbers are not included. The question is why aren't the numbers between negative 1 and 1? They would all give us a positive second derivative. Okay, so this is where, again, you have to be careful because this is a natural logarithmic function, and so here we know that the input to this function can never be negative. Okay, so let's actually find the domain of this function and see what gets eliminated. Okay, so let's go back here. Let's rewrite ln of x squared plus 1 over x squared minus 1. Okay, so we need x squared plus 1 over x squared minus 1 to be strictly greater than or equal to 0. Okay, And so what we want to do is we want to factor this as much as possible. The numerator can never be factored, okay, but the denominator can, okay. So since the numerator is always greater than 0, we only have to look at the denominator, okay, and x squared minus 1, or x plus 1 times x minus 1, okay, can be 0 at negative 1 and 1, and we know that since this is a quadratic with a positive leading coefficient, we see that between negative 1 and 1, the denominator is going to be negative, okay, and that's not acceptable for our input, the input to the natural logarithmic function, okay. So since we're excluding all numbers between 1 and negative 1 inclusive, that's not part of the domain. For every other x value, we see that the second derivative is going to be greater than 0. So this is positive for all x except x between negative 1 and 1.